Hello, everybody. I would like to give you a very warm welcome to our webinar about synchronous reluctance motor. I'm Andrea Bovo, Technical Manager at KEB Austria, and I'm here to present you a lot of new stuff about synchronous reluctance motor. And sitting near me, there is Mario Zellhofer.
Hello, everybody, also from my side. I'm Mario Zellhofer. I'm Field Application Engineer at KEB Austria and responsible for project planning, commissioning, and service.
Okay, so let's start with the presentation. Driving the synchronous reluctance motor, the advantage of a game changer. So first of all, I would like to make a short introduction about the company OEMer. OEMer is a partner of KEB Austria. It's an Italian company located in Milan. Traditional company, already 70 years on the market, with an yearly production of about 9,000 motors per year, and for sure with all the certification you need for quality like ISO 9001 and so on. KEB Austria has a special focus on the OEMer product, for example, for synchronous reluctance motor, shortly called SR motor, and for square frame asynchronous motor, also liquid cooled. And for sure, you can buy this system directly at KEB Austria, the motor and the drive, because we take the system responsibility for this. So we go forward with the presentation. I would like to give you a short overview about the evolution of the motors in the recent years. We can start from the ISE asynchronous motors, also shortly called ISE ASM, which you can see they are quite simple motor with a good price, but if you fix the power, then compared to the other, you will have a bigger size. Therefore, as you can see in the presentation, these square frame asynchronous motor are born and be developed. The target of this motor is to have a high torque density. This means to have high performance in a small volume, and also to have a lower inertia in order to fit to to good quantity of industrial applications. The further step of evolution is the permanent magnets synchronous motor, which is still a square frame motor, but the rotor has permanent magnets inside. And this gives you the possibility to have a high efficiency, high dynamics, and the lowest inertia compared also to the synchronous motors, and a high overload. And the final step of evolution is the synchronous reluctance motor, which is square frame in case of OEMer, and it combines the advantages of the servo motor and the one of the synchronous motor. So from the synchronous motor, the synchronous reluctance motor are taking the robustness, the simple design, and the service can be done in an easy way. And for this reason, it can be done also locally, also in basically worldwide, because you don't need any special tools or any special high skills for making this kind of services, as for example is required by a servo motor with magnets, which are a bit tricky to be manipulated in case of service, and you need some special tools and know-how. So the synchronous reluctance motors are very, very easy to maintain. And from the synchronous motor, they take advantage of high performance, high efficiency, high overload, and dynamics. So as you can see here in this part of the slide, this is the rotor. It has a special pattern, and now Mario is going to tell you how it works and which are the physical characteristics of this motor.
Andrea? So, what is now different in a synchronous reluctance motor? What we already saw in the slides before, maybe the main parts of the motor is the same, so we can reuse a proven technology. At first, of course, the stator of a square frame ASM motor, also the shaft, the bearings, the housing, shields, fan, terminal box, everything is the same. What is new is just a completely new rotor design. So within a ASM rotor, we have many grooves around the lamination to build up a squirrel cage. And viewing on the inductance in this rotor, we could say it's a symmetric design. So on the rotor of a synchronous reluctance motor, we have mostly 4, possible would also be 6 sectors. So we could also say 4-pole or 6-pole motor with a specific pattern of the lamination to get an aligned flux. And also viewing on the inductance in this rotor, we could say it's an asymmetric design. So this asymmetric design now has to be handled by an inverter. It is not so easy to control such a motor like an asynchronous machine. So we have a complex control algorithm which is needed to be implemented within the inverter. This control handles the proper run of the motor. Our S6 and F6 drives are designed to handle such a synchronous reluctance motor. So it is an intelligent drive planned on a modern development platform, and it has a dedicated control algorithm ready to use for the customer. So also the startup is quite simple, thanks to a default parameter setup and a wizard which provides an easy way to handle the motor. And of course, these motors can be used in all modes of operation, like velocity mode, positioning mode, or torque mode. And finally, the motors can be handled with an encoder or without an encoder. So, why is this name of this motor, reluctance motor? Viewing again on the lamination of the rotor, we can see there are high reluctance ways and low reluctance ways. So, of course, everywhere where is iron, it's the low reluctance, because reluctance is the magnetic resistance. So, and in the pattern we see air gaps in between, which are placed in a certain way to get the flux exactly through the iron. So, due to this pattern, the rotor will always follow the field which is produced by the stator, and we will never have a slip in the rotor like with an ASM machine. So here we can see it a bit more in detail. The stator produces the field in the Q axis and at D axis, and the rotor will always follow this field exactly. So, what are the advantages of such a rotor or motor? Of course, we have the big advantage that the rotor does not need magnets. So we have a rare earth-free solution, which makes it also more price stable against synchronous motors. What Andrea already mentioned is the easy maintenance and repair. You don't need any special tool or skills to get out the rotor of the stator. It can easily be done by nearly everyone or every motor repair center around the world. What is the next big advantage is that we have more or less no losses in the rotor, because there is no squirrel cage which produces heat like an ASM machine. So we get a very high efficiency. And additionally, the rotor stays cold, so this helps also the bearings to get a longer life. So here now, out of a test of a 55 kilowatt machine, we have compared the losses of the motor. And you can see the big red part are the losses in the rotor itself. And these losses are not no more present here in the synchronous reluctance machine. So, of course, all the other losses, like in the iron, stray losses, winding losses, is all the same nearly, but the rotor losses are away. And here is the compare of the efficiency. This is also a very big advantage of the synchronous reluctance motor, especially for part load of the motor. The efficiency is much more higher compared to an asynchronous machine. Here again, the compare of a 55 kilowatt machine. At nominal point, we have a better efficiency grade of around about 3%. And if we compare this gap at the lower speed or a part load point, we gather much more efficiency than with an asynchronous machine. So here the next overview, comparing this 55 kilowatt machine. If we would use a traditional IEC motor, we would have a 280 millimeter frame size and let's say medium efficiency of the motor. So an ASM machine with a square frame housing would reduce the size and space we need, but the efficiency is quite low. A synchronous machine would stay in the same size, of course, but the efficiency would be higher than compared to the other ones. So now finally, the synchronous reluctance machine, of course, stays also in the same size, and the efficiency is also improved against to the synchronous motor. So this was my part. Now back to Andrea.
Thank you, Mario, for your great presentation. So let's have this last part of the presentation. Synchronous reluctance motor you can have from the company OMR in a range between at about 3 kilowatt to 426 kilowatt. This means a torque of about 22 Newton meter up to 2,300 about. Talking about speeds between 1,000 and 2,600 RPM. And yes, for the protection class, you can have IP54 or even the version for IP23 is available on request. The perfect couple is together with our KEB F6 Drive. So our F6 are available with a power up to 450 kilowatt. If you talk about one single drive, you can run up to 1 megawatt if you combine this in parallel. Of course, for being able to fulfill all the requirements of different control supplier, we have the possibility to have a multi-field bus interface, so you can run different field buses like Ethercat, Profinet, PowerLink, Ethernet IP, Varan, and Canopy. So basically everything on the market. And for sure, you can have all the safe motion function inside the drive built in. And what you can only have at KEB is the encoderless safe motion. This means without the encoder, so you can save the encoder, the money for the encoder, the money for the encoder cable. And you can have the same safe motion as well, certified from TÜV, and simply available on our drive. For sure, you can control the motor in velocity mode, position mode, torque control, everything as usual. And an announcement to what I said before, for sure, the couple, so the motor and also the drive, both devices are available also in liquid cool. For the motor, this means a reduction of the noise and a reduction of the size. For the inverter, this kind of efficient cooling system gives the possibility to keep the temperature lower and constant, and this is a big benefit for the electronic. And it results in an increase of the lifetime. So you can talk about 10 degrees Celsius less means at about double the lifetime. So it's a big benefit for the drive and for sure for your machines, which can have a longer lifetime. So finally, where can be used this motor? We have seen basically it's a general purpose motor because we have all the advantage of an asynchronous motor and of the synchronous motor. So you can use it in the plastic industry for injection molding machine, extruder, for example, also as main extruder motor or for blow molding. But it works perfect as for shredder application where you need a high overload, and this synchronous reluctance motor have definitive this quality. Soap mixer is similar to shredder application, so you have also this situation, and wire drawing, hydroelectric power station, steel tube forming, cardboard processing line. So basically it's a general purpose motor with lower inertia lengths compared to the synchronous motor. Therefore, yeah, feel free to use it in many applications. So last but not least, this is a very interesting topic about the startup. The startup is very easy, and we hear sometimes on the market that our customers are a bit afraid of this technology, maybe because they have some bad experience with some other situation and some other supplier drive. But as we developed an algorithm, special algorithm dedicated to this kind of motor, you can feel confident that this startup will be easy. And also the startup process, we've thought about it, and basically we can reduce it into situation. The first one is that you are buying from us the couple, so the F6 and the synchronous reluctance motor from OEMR. In this case, you will get a parameter set from us. You can simply download it, and the motor is already running. In case you will take any other synchronous reluctance motor from the market, because of course we are also open to sell the single component, the startup will be as easy as usual. So you can have an identification run, which is available also for this kind of motor technology. And after this identification run, you can just run the motor. So, but this is just talking and explaining it at the PowerPoint, but Mario is now going to show it live on our test bench. Let's go.
Let's go there.
Yep.
Hello again, now from our test stand at KEB Austria. I will show you how to start up this 18.5 synchronous reluctance motor with a 19 F6 drive controller, which you can see in the background. As we already told you before, the KEB drive package comes with a ready-to-use parameter setup. The only thing you have to do is to download the list and go on with some fine-tuning, like fitting the speed controller to your application. Let's do this now. At first, I want to set back the inverter to factory settings so that you can see that the download really works. Let's reset the drive now. This will take some seconds. In the meantime, we can already open the setup list. And wait for the drive until it's ready again. So reset is completed now. We can switch to the setup list we have generated before. Just open this list and download to the drive controller. While the download is running, let us have a short look to our motor and inverter here. As you can see, we have a standard motor connection with power and feedback cable. But we will drive this motor without encoder feedback with KEB's SCL motor control mode. Therefore, of course, I will remove the encoder cable. Without the feedback, we have less dynamics starting from standstill, but we are able to handle the acceleration at least with the motor nominal torque. For example, this could be the solution for your extruder application. Let me show you when the download is ready. So it is ready now. We can close the parameter list, and I have prepared another small list to start the load machine and also the test machine. This motor has a nominal torque of around about 120 Newton meter, and this is also the value I have set up at the load inverter. So let's start now. The next minutes there will be some noise coming from the HF injection we have to use for the sensorless control mode. As you can see, this couple really fits together and works absolutely fine. If you already like this, you will definitely like the performance and dynamics with encoder. Okay, so far, this was our short practical part on this Tech Tuesday. Thank you very much for your time and attention. I hope you enjoyed this session. Now back to Andrea for some final words. Goodbye.
So, thank you, Mario, for showing us how simple the startup of a synchronous reluctance motor can be. Well, that's all for this webinar. I hope you enjoyed our video and that you could find new interesting information about this technology. Now, get in touch with our sales partner in your country and let's talk about new possibility of using this technology in your application. We will be glad to help you with the sizing of the motor and the drive. I'm sure that the benefits of this synchronous reluctance motor can be an added value for your machine. Greetings from Austria, from Andrea Bovo and Mario Zellhofer. Bye bye.